differential equations we're looking at now are of the form dy dx equals a function of x, and you can also think of these, they are called separable differential equations. Separable means that you can separate out the y's and the x's so that you have all the x stuff together on one side of the equation and all the y stuff together on the other. So there are a couple of ways to do these differential equations. I'm going to show you a way where you separate your variables out and then integrate both sides. So it's all about separating and then integrating. So if we look at the first one, we're asked to find the general solution. Now the word general solution means you're going to have a plus c in your answer because you don't have any conditions to help you find what plus c is. So if we have a look at the first one, a, we've got dy dx equals x to the fourth minus 3x squared plus 2. What I'm going to do is I'm going to move all of the x stuff onto one side of the equation and all of the y stuff onto the other. Now I can see that dy is already on the left side, so I don't have to worry about that. All the x stuff I'm going to move to the other side of the equation, including the dx. So you can see all I've done is just brought the dx up. Now the nice thing we're going to do here is simply integrate both sides. Oops. And all I'm going to do that is literally put integral signs on each side. Now the question here would be, what happens over here? We've got an integral sign and a dy. Well, when you don't have anything written in there with a dy, what you do actually have is a 1 times dy. So you've actually got 1 times dy, and here you've got an integral with respect to dx. And the thing that you notice is that the integral, as it's expected, is bounded by a dy or dx, which tells you what you need to integrate with respect to. So on the left side, we integrate with respect to y, and that will become, the integral of 1 will become y. The integral of the right side will become x to the power of 5 over 5 minus 3x cubed over 3 plus 2x plus c. And so our general solution is y equals x to the power of 5 over 5 minus x cubed plus 2x plus c. So what we've done is we've separated out both the x's and the y's to each side. Generally, whatever is underneath here, bring that up, okay, to the right side. So we've separated and then we've integrated both sides to get our general solution. So if we have a look at the next one, we've got b, we've got dy dt equals sine of 2t. I'm going to do the same thing again. Bring the dt up to the left side. So dt. And then all we're going to do is integrate both sides. Boom, boom. Remember that this is the integral of 1 dy, so that becomes a y. Integral of sine is going to be negative cos 2t, and because we're integrating, we divide by the derivative of the bracket there, and plus c. So that's our solution for b. The thing here as well is that you can actually check your answer. And I didn't do this with the first one, but I'll do that with this one. So if we actually differentiate our answer, dy dt equals negative cos, the derivative is going to be sine, and the 2 will come out the front. So it'll be 2 sine 2t over 2, and the constant will disappear. So we end up with dy dt equals sine of 2t, which is what we started with. So you can check your solution to a differential equation by actually differentiating it and then comparing it to what you had to start with. So we're just going to look at now the next two, C and D. I'll just put this over here so we can see. It's pretty much the same routine that you use for all of these, to be honest. It's just about separating out your derivatives and identifying what you need to integrate. So I'm going to separate out the dt stuff to the left side. Oops, let's write that a bit better. So negative 3t as the power and 1 over t, and the dt has now come up from underneath. I'm then going to integrate both sides. So what I'm going to do is integrate. I'm going to put a 1 here because it can look funny with just the integral and nothing in there. Integrating the right side as well. Integrating the left side with respect to x, we get x. Integrating the right side with respect to t, oops, we get e to the negative 3t divided by negative 3 plus the integral of 1 over t is log of t plus c. Now you might have wondered at this point too, how come we don't write a plus c on both sides of the equation? Well, I can do that and show you why. So if I wrote a plus C, I'll call this C1, and we'll call the other one C2. What I could do is rearrange this so I'd have x equals, I'm going to take the C2, the other constant, over to the other side. C2 take away C1. Now this whole part here, C2 take away C1, is also a constant. And because this whole thing is a constant, what you could do is simply relabel that so that you had x equals e to the negative 3t over negative 3 plus log t plus, I'd just call this k, where k is a constant. So you can just relabel. So that's the reason we don't bother putting a constant of integration on both sides, because we could just combine them into a single constant. So that's our general solution. And again, you could differentiate that. That's a nice activity to do, see if you can differentiate to get back to what you started with. The last one, D, you've got dx over dy equals 1 on y plus 1 plus y squared. And again, we're just going to separate things out. So y squared plus 1 and dy. Now, hopefully you recognise this as one of the standard integrals that you've done before. So we're going to integrate both sides now. Just add a 1 to the left side so it doesn't look so funny. And this right side here is actually an inverse tan. So we're going to have x equals inverse tan of a is equal to 1 here. So it's going to be y on 1, which is just y, plus a constant. And that's our general solution. Remember, a general solution is a solution that has a constant of integration in there that hasn't been solved for a particular value. So the key here is to separate out your dx's and your dt's, or dx's and dy's, whatever your derivative parts are, integrate both sides of the equation, and then solve. You essentially with these solve for whatever's on the top. So you can see here in C we solved for x because it was on the top, and in D we solved for x because it was on top. So that's the idea of solving differential equations of the form dy dx is a function of x, or any other variable here, the same type of differential equation. And just notice there to finish off, missing a mod, really important with your logs. Put that one back in.